Go ahead.
Hello, everyone. I'm Michel, and I'm going to talk about using Hyperscale as a staging ground for Fedora improvements. Since we had an earlier Hyperscale talk, some of this material is probably not new, and you can just refer to the talk, and I'll skip over the part that's we've just heard about. So a little bit about me, I'm currently a production engineer at the Linux user space team at Meta. We ran one of the largest CentOS stream deployment, probably. So this kind of informs this talk. I've been a long-term contributor for Fedora. I mostly do packaging in the Rust, Python, and Golang ecosystem. I do a lot of stuff with Apple, which should be familiar to most people here. It's the project that maintains the repository of extra packages for enterprise Linux. And I'm currently a member of the engineering steering committee. And on CentOS, I'm active in the Hyperscale SIG and to a lesser extent, the alternative images. So let's talk about how normally packaging works, from Fedora all the way to Red Hat Enterprise. Basically, Fedora is the upstream for CentOS stream, and every 3 years we branch off from Fedora, and then CentOS stream got stabilized to be the Red Hat Enterprise Linux point releases every 6 months or so. So if you want the latest and greatest, you go to Fedora. I'll just skip over this part. And then we have Hyperscale. And as David and Neil mentioned earlier, basically it's a collaboration between some hyperscalers who basically have certain needs that they need to do when running CentOS at scale. And it's not limited to hyperscalers. You can basically, anyone can join. I have a pet project that I hope to be working in the next few months. Basically, using enterprise Linux as a basis for a proper desktop. Basically, think of the equivalent of Ubuntu LTS. Hyperscale is built on top of CentOS stream and Apple repository. And mostly it's a combination of different things. In some cases, you have just CentOS stream packages, but rebuilt with some features re-enabled. In a lot of cases, we need a newer version of a package, so we backport from Fedora. This talk is going to be about this rarer case where we actually might have things that are not even in Fedora yet. So for those who have not seen this yet, this is from the Red Hat application compatibility guideline. RHEL has 4 compatibility levels. 1 is the strictest and 4 is the least strict. That basically talks about how long a package is guaranteed to be API or ABI compatible. So as you can see, for compatibility level 1, the ABI will be compatible even 2 major releases down the road. For compatibility level 2, it's only API and ABI compatible for 1 point release. So with CentOS stream, basically, since it's going to be the next, it will eventually turn into the next point release for RHEL. We basically only have compatibility level 2 at the most. Not always, because obviously, there are bugs, and sometimes compatibility level is accidentally broken. So, if you want to live a bit on the edge and you can cope with this, then it's fine to run stream in most cases. Part of the reason we have Hyperscale is because there are some packages that we cannot maintain in Apple because Apple only complement and cannot replace RHEL and CentOS packages. In some cases, you can. A lot of the pain points is that sometimes the packages built in RHEL or CentOS stream, the development sub-packages are not shipped. And sometimes there is, it takes time to request that they be shipped. The maintainer just refuse to ship them. And then you can maintain like kind of a parallel package in Apple that closely track the CentOS stream package, but it's a bit annoying. So in Hyperscale, as you can see, like from the previous slide, we have packages that replace RHEL packages for multiple reasons, whether to just enable some features or we need a newer version. There are some limitations, of course, like, we are a growing SIG, but we have 30 people, and like people mostly work on things they are interested about. So we don't really want to do a hard fork and like maintain a full distribution. So we try not to touch key packages. Like we're not going to ship, like a newer TCC compiler in Hyperscale. And we also don't want to like break ABI compatibility if we can help it. So that means that at some point you cannot, we have to stop maintaining certain things. Like at some point when we were still supporting CentOS 8, we cannot actually build newer kernels anymore. If I remember correctly, the kernel itself builds, but some utilities that are built as part of the kernel no longer builds because they need newer compilers. And I think Neil mentioned earlier, like we still don't have circuit boot signing, which means like our hyperscale kernel is still in experimental. We don't want to put it in the stable repo yet. And testing is a bit of a pain point, like for SIGs in CentOS. We don't have like the gating mechanism that CentOS Stream and RHEL has. We also don't have body like in Fedora. So basically, there's no official way to solicit feedback for a package and stop packages that have bad feedback from being promoted. I'm going to go through some examples of like what we're doing in this talk, like where we develop ahead of Fedora. RPM with copy on write. This was talked before in the previous talk. Basically, if you have a modern file system like Btrfs and XFS, you can take advantage of reference linking and basically reduce a lot of I/O and disk space usage by just basically sharing files, sharing extents between your package cache and the actual files on disk. Systemd, where like we actually deploy the latest and greatest Systemd, which will be like updated much more often than even Fedora, which rebase Systemd every 6 months. The Intel like a zlib package with AVX optimizations. And I'm going to talk in more details about some examples that we have not talked before. Linux firmware. The packaging in Fedora is much more modular than the packaging in CentOS, which is kind of great because when you run a server, especially if you manage like your fleet and like it's mostly like a monolith, it's mostly homogeneous and you don't have like that much variance in hardware. Most of the firmware that you get in Linux firmware is actually basically dead weight, and it's just wasting space on your server. This CentOS 10 probably has a modular one from Fedora. I have not checked, but in CentOS 9 it's just a big package, just like 200 or 300 megabytes. Basically, like we brought the Linux firmware from Fedora with we put up some PRs to actually like separate AMD firmware into its own subpackage. So this basically allows us to not only like save a lot of space on our server fleet, but also like if you work closely with like a vendor hardware and a hardware vendor, and they give you newer firmware, you can like just replace certain subpackages without basically dealing with RPM, like corrupting your RPM installation by replacing files that comes from a different package. MST Flint. This is the Mellanox firmware updater package. It's we have a newer one in Hyperscale as of a few days ago. The Fedora version is actually stuck a few versions old, and there's some weird issue preventing newer versions from compiling. So still debugging that. And perf, for those who are doing performance profiling, this is one of the main tools used. Perf is interesting because it's in Fedora. It used to be shipped as a separate, as part of the kernel utils package, separate from the kernel, main kernel package itself. Whereas in CentOS and in Fedora at the moment, it's merged back into the original kernel package. This means that whenever you want to change the packaging for perf, you have to rebuild the whole kernel. And as I mentioned before, at some point, it will be harder to build the whole kernel package for an older CentOS release because it might stop working with older compilers. Perf actually released a standalone software release that most distributions are not using yet, and we are still working on it. But Hyperscale could be the first testing ground for having a standalone perf package that can be built and maintained separate from the kernel, and separate from all the other kernel tooling. Some observations from doing all this work. I mentioned earlier that SIGs don't really have a good infrastructure right now for actually doing testing. Hyperscale is kind of lucky in that we basically we leverage our member companies' own internal mechanism to actually do the testing. I can't speak for other companies, but at Meta, we have basically our own mechanism for pinning packages and for doing rollouts. So we basically test in production, but but with a careful rollout, and we can so we notice issues that we might not notice in unit testing or even functional testing. CentOS has a stable base compared to Fedora, so it's kind of nice when you change one thing and something breaks. You don't have to basically try to did I break something, or did the package break because of some other changes? In Fedora, you might notice that even rebuilding a package in Rawhide might fail because some dependencies have been updated. And necessity is the mother of invention. So sometimes we notice issue in Hyperscale, hey, we might want to package certain things differently to make it more resilient and updatable when a distro gets too old and certain parts no longer compile. So yeah, I guess we are running ahead of time. I'll just open it for questions, and I'll mention that we are always looking for suggestions and more contributors joining. Well, that's fast. Are there any questions? Let me check Q&A. No question yet?
Nope.
Let me check the matrix. All right, if there are no questions, we can just chit-chat until the next talk, I guess.
Cool. Thank you. All right, I will we got 16 minutes.
Oops. Neil, was that question for my talk?
Yes.
What's the most convoluted thing you have had to deal with? I would say kernel, packaging perf, in that at some point we switch Hyperscale to basically building the perf package, the kernel. Is it kernel tools or kernel utils?
It's
the
kernel
one
tools.
from Fedora.
It was kernel tools.
It was really janky, trying to build you just want to re-enable some features in perf that's not enabled yet. It will work when you build it by hand, and then when you build it as part of the RPM, it stops working. And I noticed at some point, I think Justin Fox gave up on it and say, okay, let's just build a single package again.
Yeah. I think this actually recently bit me when I was trying to release a new kernel for Hyperscale, where like it actually failed, not because the build failed, but because the version string didn't actually change for the sub package at all.
Oh God, yeah, it's not meant for that, right? Like they kind of assume, oh no, your kernel is too old, and no, it's not.
Yeah, and it's just like, oh great. So
I think, yeah, Perf is probably the best use case for like the first tool that we should split out from the kernel, because the Perf maintainer actually wants people to build separately. It's just that nobody's doing it, so the package is now actually kind of buggy, which nobody noticed.
Yeah, I mean, Perf is one. BPF tool was another. I think the BPF tool is actually now getting split out.
Yeah, I think BPF is still in the kernel, but a lot of the BPF utilities are mirrored on GitHub, so they can be built separately.
Yeah, I think BPF was actually the most recent one where I saw this, like these megalith packages, which have actually things with different version release strings in the sub packages, are annoying, is the way I would put it. Kernel Linux firmware is the same way. They have sub packages with different versioning. Because
although it's not that hard to build, though. So like I've not had issues with it yet.
I think it's just because we're just straight up backporting from Fedora, so they're always bumped. But like,
but yeah, you're right. It's true. Like sometimes, like I only update it whenever there's a request for some internal features, and it's really a headache trying to correlate the version numbers that they get from vendors to what's actually in the package.